Let's talk some stats here. Chapter 6, Section 3, little Poisson, probability distribution. All right, what's the purpose? What's the deal with this thing? Well, we're going to figure out some probabilities, but there's some criteria that got to be met first. So here's what we got to have. 3 criteria got to be met for this to be used. And they are only one success at a time. With any 2 intervals, the probability of success is the same. And then the number of successes, easy for me to say, are independent based on different intervals. Okay, so before we get all freaked out about it, our main difference is there's a fixed period of time. That's going to be our interval. So we're figuring out some probabilities over a fixed period of time. So here's what our formula is going to look like. Now, I want you to know the formula, but you're not going to do this formula. Some of your calculators will overload with some of the numbers we're going to be having in it, and they won't be able to do it. They just don't got enough readout or enough memory in there. So we'll show you a way around it. So first of all, probability of x would be, this is lambda, our expected value, times t, all over the x factorial. So we'll be doing that. This is negative lambda t. So if I got this, I just take the negative and use the power here. And e, you learned this back in Algebra 2, maybe even a little bit before, but definitely learned it in Algebra 2 when you were doing logarithmic functions. E is used a lot in terms of figuring continuous interest. So you recall that it's 2.71828, and then so on. It's an irrational number, very similar to pi. So we're going to be using some calculators online in order to help us figure these things out. So don't fret too much about it, but in terms of doing the problem and setting it up, we do need to know that. So what is t? That's our fixed length of time, our interval, if you will. X will be the number of successes, and then lambda is going to be the average number of occurrences of an event in some interval. Average number of occurrences in some time. That's what our interval is. Okay, in some time. So let's look here, shall we? Here's a problem for us. In any given lunch period, 20 PB&Js are sold. What's the probability of selling 65 PB&Js during the lunches? All right, let's look into that, shall we? First of all, let's get labeled. What do we need? What's going on? You know, going back to what we just had, we need x, we need lambda, and we need t. X, lambda, and t. Okay, so let's go. No particular order. Let's go x. And x was the number of successes. Well, what do we want? Our successes are 65 of these things being sold. So x is going to equal 65. T. Yes, recall back in the day when we had lunches. How many lunch periods do we have? We have 3 lunch periods, so we'll use that. Different schools, different lunch periods, and so forth. And then lambda. Lambda, going back, the average number of occurrences. Well, in any given lunch period, 20 of them. On average, 20 of these things are being sold. So there it is. 20 per lunch period. So that's where our average is, right there. Okay, so what do we do? Well, we're going to plug this into the formula, is what we'll do, and then we'll show you how to get around it. So we want the probability of what? 65 PB&Js. Well, that's going to equal now the average. The average of success, that's going to be lambda t. Well, here's lambda, here's t. That's going to be 60. Again, back to that formula. So lambda t will be 60. And that's raised to the power of x. What's x? 65. That's where some of your calculators are just going to say, we're done. You're asking me to do too much. Over, our formula had x factorial, 65 factorial, times e, yes, your calculators can get that for you, to the power of negative lambda t, or in this case, negative 60. Negative 60. Now, ladies and gentlemen, again, the calculator I use blew up. So, what do? You go to Stat Trek. Let me get a different color here for this. Go to Stat Trek, the website that we use for the binomial probability, and on the left-hand column, scroll down there until you see where it has the Poisson probability. So go ahead and do that. So once you get to that stattrek.com, on the left hand side, go all the way down to where it says Poisson. Click on it. In the random variable x, that's where you'll plug in 65. That's what x is. For the average rate of success, that is lambda t, 60, you plug in 60. And then you get all the possibilities. You got what if possibilities for the cumulative. If it's greater than that, less than that. Our concern is equals. So the probability of 65 PB&Js being sold during the lunches when we're averaging about 20 is, and you can see the decimal reads out, 0.04035. Remember, that's a decimal. To change the decimal to a percent, move it 2 places to the right. I think some of you messed up on that on the last assignment we have. So you got about a 4% chance of selling 65 of them. You're averaging 20 a lunch period. What are the odds of you selling 65 during all the lunches? About 4% chance. But we're using this calculator to do all that work for us. So let's look at another example with this. All right, I don't know, I must have food on my mind here. Let's say McDonald's averages 2 cars a minute at the drive-thru lane during a lunch rush. Find the probability of serving 6 cars from 12 o'clock to 12:05. So in a 5-minute time span, find the probability of serving 6 cars. They're doing 2 cars a minute as we do this. Okay, well, let's see what we got to do. We got to have x, we got to have t, we got to have lambda. Let's figure this all out. So x, what do we want? We want 6. All right. Time, what is our time? 5 minutes. So we're going to have a 5-minute, easy for me to say, 5-minute time frame. Lambda was what? The average. Well, we're getting 2 cars per minute. So our average is 2. And then lambda t is equal to 10. And I'm pretty sure most of you are going to jump to this and not fill out the formula and just going to tell me that the probability of 6 cars being served in that 5-minute span, when I go to the Poisson calculator, in place of x, we put a 6. In place of average rate of success, in this case, we got a 10. We hit calculate, and boom. We get 0.06306. 0.06306. Meaning what? You got a 6% chance of that happening. 6% chance of that taking place. So it's over a time period, though. That's the difference now. And finally, a piece of information here. For the mean of the Poisson random variable, if you want to find the mean of it, that's lambda t, our expected value. lambda t. It's also, remember, average, mean. Find the standard deviation. We'll take the square root of lambda t. Standard deviation will be the square root of lambda t. All right.